Friday, I think we started with group theory. So we just listed various symmetry operators. There are 5 symmetry operators: identity, rotation, plane, inversion, and improper rotation. So we just finished till rotation. We started with mirror plane. So we were talking about different mirror planes: sigma v, sigma h, and sigma d. Right. Um, so for ammonia, I think I gave for working out. Anyone tried for ammonia molecule? What are the symmetry operations possible?
Yes, sir.
Yes.
Yes, sir.
Can someone tell? Robin. Yes.
Yes, sir. So ammonia has one identity, two C3 axes, and three sigma V's.
We're using RBs. Okay. So C3 it has how many C3s?
Uh, Two C3s because third C3 will be identity.
Sorry.
Two C3s axis because third C3 the C3 3 will be identity.
Okay, but still it has C3 3 also.
Yes, sir, because that will be counted in identity only.
Yeah, yeah, it is counted as a identity, but still it has third one also, C3 3.
Yes, sir. Yes, sir.
Okay, so this is what just did it. Others, you please work it out. Um, so I think I've sent the link. I think right, video link and yeah, I think video link I sent. Those who missed the classes, they can go through the video link. Um,
Excuse me, sir. Sir,
yeah.
sir, I cannot download the video that you have sent or you have shared.
You cannot download. Is it
No, sir.
viewable or not?
Yes, it is viewable, but I cannot download it.
Oh, you're not able to download it. Okay,
No,
maybe I
sir.
didn't give the editing rights. I think I just gave the viewer rights.
Okay,
That's
sir.
I can change it. Okay, today when I
Oh,
upload today's talk lecture also, I'll change it
okay.
to editor mode. Okay,
Thank you, sir.
that's fine. So you want me to take the attendance? Actually, is it necessary? I don't think so. I generally have a what extension in my Google Meet which automatically picks up the attendance. So I don't have to take the attendance, right? Okay, so it automatically picks up and then gives in Excel sheet. So I'm not just going through your attendance list. But anyway, I just want to know there is one international student. Did he join or not? I just want to check. His name, I don't know, Adolescent. No, I don't see his name. Okay, so actually one international student has registered, he has confirmed the admission. So we send the link, but he has not joined. Okay, it's okay, fine. So the board is visible for everyone?
Yes, sir.
Yeah, yeah, no problem. They could see those who, I mean, one of you had problem in viewing the board on Friday. I hope this problem is not that. Okay, let's go to the reflect. Continue. Let's continue where we left. Mirror plane, right? Symmetry is mirror plane. So we saw sigma v, sigma h, and sigma.
Sir,
Yes.
sir, the corners are not visible.
What is not visible?
The sigma V that you have written, it is not visible.
Not visible.
And the group theory G is not visible.
Okay. No, I didn't write group theory at all.
So
So
that what six planes, there's something that you have written. Mirror planes, yes. The mirror planes, the mirror is not, only OR plane is visible.
what is not visible? I think I could
The
see.
mirror planes, you have written the mirror plane, right?
I have written mirror plane. Yes.
The mirror part is not visible, only OR plane part is visible.
Only plane part is visible. So mirror is not visible.
Or
So-
plane.
This is not visible. Mirror.
The mirror part is not visible.
Sir,
Yeah. Somebody else.
sir, this is visible on the laptop screen, but in phones, the corners are not visible.
In mobile phone.
Yes, sir, but in laptop it is visible. So that's why this problem is coming.
I just put a little bit. So mobile users, mirror is visible or not? No, not yet. I have rewritten again. Mirror is visible or not? कुछ तो बोलो.
Visible, sir.
Okay, fine. So I think we saw sigma V, sigma H, sigma D. Good example is XE, X4. There are many examples. We'll take XE, X4. Okay, so XE, you can say it's a square planar. Yeah. Okay, so good example for sigma D is XE, X4. Sigma D is there are at least two definitions. One is plane which is bisecting two sigma V planes is sigma D. So in XE, X4, it is what are the elements are there? Symmetry elements. So E C4. C4 is that in XE X4. So molecule is placed on the plane. It's planar molecule, and then say axis is passing through this board. Okay, so if when I write a dotted line, it means it is passing through this board. So you can have C4 and C2 also possible. Okay, so if you rotate it, this F can go to here, and then it automatically goes. C2 is you rotate 180 degrees. Yeah, so there is C2, and then sigma. What else is that? Sigma H is there. You agree? So if you take a sigma H plane, which you just place it over this molecule, so this will just give you a mirror image, indistinguishable image. So the sigma H is present, and then how many sigma V? Sigma V is also there. So can you tell me how many sigma V is present?
4 sigma V's.
Sigma V, I can place it over this molecule, and then this line. And then I can place it. So basically, it is okay. So basically, there are multiple sigmas, sigma V's. One definition of sigma D is a plane which bisects the two sigma V plane. So that is sigma D. So I can say this sigma V prime, sigma V double prime. So if you bisect this molecule into two, cutting the sigma V planes, then it is called as sigma D. So this is one sigma D. Yeah, and similarly one can have another sigma D here also. So that should be at least two sigma D planes. So you have to imagine the molecule is placed on this board, and then principal axis is passing through this board. So the principal axis is C4 and principal axis of rotation, whereas C2 is another axis of rotation, so that we are not considering. But so C4 is passing through this board, and then you have a sigma V plane which is placed over XE FF atom, and this side also XE FF atom, and then if you place a mirror which is placed over this molecule through. Yeah, you can place it like this, or you can place it like this. So both are sigma D. So basically, sigma D means it's just what? It will just bifurcate the sigma v planes if the molecule has. Okay, so that is one definition for sigma d. I
Sir,
can give multiple definitions for sigma d or examples for sigma d.
sir,
Yes.
sir, will you please explain sigma H for the same molecule again?
Okay, sigma h is very simple. Any planar molecule generally will have a sigma h plane. So, for example, let's take BCl3. So Cl, Cl, Cl. Okay, so I'm just considering another example. So this molecule is planar, BCl3, and this will have a plane of symmetry, right? So if you place a mirror on this board, if the molecule is placed on this board, and also you place a mirror cutting this board, then you have sigma h plane. Similarly here, I have just drawn XeX4. Xe, any square planar complex will have sigma h plane. So sigma h is basically which is perpendicular to the principal axis of symmetry. So in
Okay,
BCl3 molecule, it has what? C3 will be there, right? C3 is passing through this board. You have a arrow mark here, and you can rotate it. So this is C3. So you can rotate by 120 degrees. You will get back the equivalent structures. So that is C3. And then if you place sigma h plane, which is perpendicular to the C3, so like place like this, then you have sigma h plane. If you place along the axis of symmetry, then it is sigma v.
Okay, sir.
If it is perpendicular to the axis of symmetry or principal axis of symmetry, then it is called sigma h. So in XeX4, the principal axis of symmetry is C4, and you place a mirror perpendicular to the C4 axis. So if you place it on this board, and this molecule cuts into off. Considering these are all coming here, this is all single atom, right? So it's no problem, just cuts into it. You consider this in a spherical shape. This is also spherical shape. Xenon has spherical shape. Considering atoms are spherical shape, and then if you cut the molecule along this plane, then you will get sigma h. That's all it is. Sigma v means you just place along the axis of symmetry. Then sigma v. And sigma d is which bifurcates the two sigma v planes. So that's what sigma d. So these are the three types. Each molecule can have multiple sigma v or sigma d's, but it can have only one sigma h, because the molecule can have only one principal axis of symmetry, and sigma h is plane which is perpendicular to the principal axis of symmetry. So it can have only one sigma h, whereas you can have multiple sigma v's and multiple sigma d's. That's why we are marked as sigma v prime, sigma v double prime, sigma d prime, sigma d double prime, like that. Okay, so I can give more examples for sigma d. Same, similar. Nickel, CO4, you can consider. Okay, just similar, something similar to this. Nickel CO4. Yeah, this is also a good example. I think structure is similar to XeX4. Considering CO as one unit. Okay. So here we consider CO molecule as one unit or one sphere. So considering that, this molecule also has sigma d planes. Okay, you please work it out. Okay, shall we go to the next symmetry? So no reply. Okay. Already it's weird to teach seeing the molecule. So inversion symmetry, the symbol is I. Okay. So what it means is all points in the molecule can be reflected through a single point. And then the molecule is said to have inversion symmetry. For example, you can say carbon dioxide. Okay, so basically, if you from the center of the molecule, this carbon dioxide linear, right? So from this center of the molecule, if you go to both the ends, you will meet the same atom. If that is the case, then it is called as inversion symmetry. The molecule is said to have an inversion symmetry. But if you take some other example, like which example you can say? HCN. HCN is linear. I'm not sure, but anyway, fine. HCN, if you consider something linear, you go to from center. If you go to different direction in both the direction, you end up with different atoms. So this molecule doesn't have inversion symmetry, whereas this one has inversion symmetry. This is one way of explaining it. Otherwise, you can think if in a given molecule, if all the atoms collapse to a central point of the molecule, then it should have it should just nullify everything. There should not be any different atom. Like if you bring both the both oxygens to the central point, then just collapse, right? Everything becomes neutral. Whereas in this molecule, I'm not worried about the bonding here. If you bring it all together, then it may not merge. I mean, it may not collapse because there are different atoms. So that's a different way of looking at it. I can give more examples. The 3D molecules I can give. Asymmetry. So the same example you take XeX4. We have taken XeX4, right? The earlier example we took XeX4 for sigma d. Here in the same case, so from center of the point of this atom, if you go in 4 directions, you meet the same atom. Okay, fluorine will be you'll be reaching. So that means this molecule has the inversion symmetry. Like this, we can say again BCl3 we saw. Cl. So from the center of the atom, if you go to 3 directions, you will reach the same atom. So that these molecules have asymmetry. Okay, in addition to others. That's what it means. From here, I think this is very important symmetry because based on this, you'll study about or will come to know about whether it is IR active or Raman active. Okay, we'll see more about this in future classes because it directly relates to the dipole moment. Okay, so this is inversion symmetry, and next is last one is called as improper rotation.
Sir? Yeah. Sir, can you please explain how in the BCl3 there is I present?
In BCl3?
Yes, you have said right that in BCl3 the inversion is present. So because what I know is I is if we go in, from center, if we go in opposite directions, and if we counter the same atom, then we say that I is present. But here we by going in opposite direction, we can't find the same atom from the center.
Yeah, so that is one way. Another way is
Sir,
You are saying you go from this to this. Huh? And actually, we have to see the collapsing. This molecule has dipole moment or not?
So this molecule will not have any dipole moment.
Then this molecule has I symmetry, inverse symmetry.
sir,
So
but this
I gave two definitions. One is going in both direction. Other way is you collapse the atoms. Like you bring the atoms to the central point of the molecule. Okay. So if you meet all together, all similar, and its effect is nullified, then or all the atoms are similar, and if everything reaches to the central point, then that molecule is said to be having inversion symmetry.
Sir, BCl3 I think belong to C3H point group, and there is no center of inversion in C3H.
No, D3H.
What point group?
D3H point group will be D3H, and
D3H.
S3 will be present.
Yes.
S2 I don't think.
But not center of inversion.
Let me check. I may be wrong. No, D3H has I symmetry.
No, sir. BCl3 do not have I
In
symmetry.
D3, you're saying I is not there. Huh?
Yes, sir.
Fine, I'll check it. But as such, what about this one? Okay, BCl3, maybe I may choose the wrong example. This will have this has I or not?
Yes, sir. It has I.
Yes, sir.
Right, because you get same atom before, right? Okay.
Yes. Yes, sir.
This one has I. I is there. What about other examples? Like, the other examples are also trans-plating of perhaps.
So you can take the example of staggered and eclipsed ethane.
Ethane staggered and
Staggered and eclipsed ethane to differentiate.
staggered has I.
Staggered has I, but eclipse doesn't have any I.
The eclipse. Okay, fine, leave it. I'll check it. Okay, so we don't want to get confused with this. As per our definition, the atom has to collapse, and then it should be considered as I. But I'll check it in next class. I'll let you know. Okay, BCl3, whether it has I or not, I'm not sure. The best way is to find out the dipole moment. I'll check it, but other these molecules have I symmetry. Okay, so this is ammonia. So here also I symmetry is present. Okay, go from different directions from the central point. You'll reach same atoms. Even if you bring atoms closer, I think it gets cancelled. Okay, so I think these two molecules has I. BCl3, I'll check it. It may not be correct. Let me check. Maybe I gave a wrong example. Okay, so I'll go to the improper symmetry, improper rotation. So its symbol is given as S, N. So S is basically so there are two operations involved in this. Rotation is also there, and so basically it is C followed by sigma C and sigma H. Both has to be there. So if you consider Sn, so Cn has to be there, followed by sigma H, then it will become Sn. If the molecule has Cn, And then if you operate with the sigma h, and if it gives a indistinguishable image, then the molecule is said to have SN symmetry. Okay, so improper rotational symmetry. So example is cyclopropane you can consider. And just consider all the hydrogens. So this is a cyclopropane. We have C3. Okay, then 3 times of C2. Sigma H. Sigma V, multiple sigma V. So how many will be there? Here, if you can place sigma V here, on this side and this side, at least 3 sigma V's are there. Sigma V, I just call it 3 times the sigma V, 1 sigma H. And then, since you have both, you have C3 followed by sigma H, both are there. So obviously, you perform. So we are rotating the molecule through this board. That's the principal axis, C3. Okay, so keep the molecule to the central point. So through the central point, if you rotate it, then these hydrogen will be going. These 2 hydrogens will be going to this 2 hydrogens. These will be going to here. These 2 will come here. So C3 acts as a gas. And then if you place a mirror cutting through this board, so basically you just cut along this board. Then if you do that, then it has sigma H. Since it has both C3 and sigma H, so it is considered as it is having S3. So it is having improper rotational symmetry also. Okay, you agree with this? Yes, sir. Okay. Okay, shall we go now to point group? So next topic is classification of molecules based on symmetry elements. So that is generally called as a point group. So for a given any molecule, one can have a classification in the terms of point group. So higher the number of symmetry elements, then we say it is highly symmetric, and then its point group will be in D or icosahedral or tetrahedral, like that. If it is having very low number of symmetry present, and then it will be in C1 or Ci. So like that one can label it. Okay, so we just go to the point group. We list out few point groups and see some examples. So there is a point group called C1. Okay, so that means it has only E and just C1, nothing else. So that is called as point group C1. Can you give me an example for this? Just consider any
unsymmetrical molecule.
have any symmetry. Okay, so just consider this. And just so carbon is surrounded by 4 different atoms. So this is having just E symmetry and then C1 because it has to rotate what? It has to rotate 180 degrees to come back to its original position. So that is C1. So this is example. Then what about C2? So point group C2. Any example for C2 molecule? So C2 means molecule has E and only axis of rotation. C2 axis of rotation, nothing else. No sigma H, no sigma V, no sigma D, or no SN, no I, nothing it has. Can you give an example for C2? H2O2 is example. O, H. And then this molecule. So this is a C2 example. So these three atoms, oxygen, hydrogen, or on.
So the open book H2O2, right? Open book structure of H2O2.
Yes, open book structure of H2O2. Yes, that's what I'm saying. So one atom is out of the plane. So if you rotate by 180 degrees, so how we can rotate? So we say this is passing through this plane, and then so this axis is passing through this this board, and then if you rotate it 180 degrees, rotate it, this atom comes to this position, and then the atom which is coming out that goes to the plane. So that is that you can consider as C2. Okay, so this molecule has H2O2 has only C2 point group, nothing else. What about sigma S? Okay, so this is CS. So point group called as CS, C subscript S. Okay, so this molecule, what it means is it has En and sigma planes. No, it doesn't have any rotational axis of symmetry, but it has only plane of symmetry. These are not very common, but still such molecule exists. SO2, BRF. So sulfur, you can say we have right definitely. So this is the example for CS point group. What it means is just En sigma. So if you place the mirror across Br, sulfur, fluorine atom, and only the oxygen will be interchanged. So this is example for CS point group. Okay, let's go to common examples. So these are very rare. Again, CI. CI is, we can see again CI. So there's a point group called CI. So it has identity and asymmetry. That's it. So example is C2, H2, Br2, F2, you can say. Br2, Br2. This you can make it up. This is CL, and this is BR. Okay, so you go from either side. So this is BR, you reach from the center of the point, CL also, and from hydrogen, you get something like this. So this point group is called as Ci. Okay, so I already told you about C2V and C3V. So its general name is CNV. So there's a point group called CNV. So that means it has what? E, Cn can have, and then n times of sigma V2. Okay, Cn and n times of sigma V. That's CNV. So for example, this C2V, we can have water as water, and what other example for C2V? Can you give me an example for C2V other than water?
SO2, sir.
SO2, yes. SO2 is one example. C3V is ammonia. Another example. Yes, can you guess any other example for C3V other than ammonia? PCl3 also one can consider.
CHCl3, sir.
Sorry,
CHCl3.
HCl3. What is that? Can you repeat?
CHCl3, sir.
CL3.
CHCl3. Yes, sir. HCl.
No, I'm not understanding. Fine, there are some other molecules, right? Yeah, there are many examples for C3V. I'll leave it there. C4V. DRFI also you can see. Okay, so this molecule C4V, BRFI, it's a good example. So BRFI structure is BR. So basically, this F is coming out of this board. Okay, so this is F is not on this plane of this BRF4 molecule, but this F is out of the plane. So this is something like this. This is somewhere here. This. So you can have C4 and what else? You can have multiples, not only just sigma V and multiple others also possible, like sigma D also possible in this molecule. You find out what are the symmetry elements present in this. Okay. So C4V, not in the C4V, but BRF5 molecule symmetry. You can see symmetry operations. It's interesting. You try it out. Okay. So next is CNH. So we have CNH. It could be the point group is say C2H. So C2H. So this molecule N2F2. Okay, so this molecule N2F2. So this will have C2H point group. So what it has is E. C2H means or CNH means you can have EC2 here and then sigma H. It has only these three things, nothing else. So one axis of symmetry C2, and then one horizontal plane of symmetry, the sigma h. So plane of symmetry you can make it, right? Let's say this is a plane of the molecule. It's planar molecule. So you can place here a mirror which cuts the molecule into half. So this is one plane. And that should be perpendicular to the C2 axis. So C2 is, say, this is passing through this. So this is like this, rotate by C2. So if you rotate it, if you rotate this molecule, this F will come here, whereas this F will come here. Okay. Again, NN will be interchanged. This N will go here, and this N will come here. So this has C2 symmetry, and also it has a plane, sigma h plane, which is perpendicular to the C2 symmetry. That's why it's called sigma h. So this molecule N2F2 has a point group of C2H. You find out tomorrow. Tell me what is the what are the symmetries present in boric acid. Okay, you have to find out the structure of boric acid, H3BO3, and then find out what is the point group. It could be somewhere here only. Yeah. Okay, H3BO3. Please work it out. Now these are C point groups. Now let's go to the point group starting with D. Am I going very fast, or is it you could follow? Yes, please, some of you say something.
Sir, it is okay for a person who has studied it before,
Yes.
but it is fast for a person who is studying it first time.
Yes. Okay. Yes. Anybody else want to comment? Is it fast? Tell me. Vivek Mehta. Robin is right. Okay. Vivek Mehta कहाँ गया? Lunch करने के लिए गया? Missing है. Okay. Sahil. Fast, sir. Okay. Then it's okay, sir. Ritik Bansal. Fast, sir. बताओ. आप लोग कुछ बताना चाहिए था. Okay for me. So ठीक है, fine. Okay, so maybe I'll slow down. But for people who already studied, it's okay, sir. I can read it before because I can read it before. Okay. Fine. So Nidhi, the PhD scholar, Nidhi, is it you have studied earlier? I hope so. May, yes, okay. Yes, sir, it's fine. Okay, fast, sir. Okay, I'll just see what to be done. Maybe I'll slow down a little bit. So far we have seen C point groups, the point group labeling with starting with C. Now let's start with the point group with D. Okay, so this is called a DN point groups. There are three different types. One is DN, then D, then H. You can say DND, and then D, N, H. So there are three types of classes: DN, DND, and DNH.